Everyone is your favorite chemist again, and adrenaline, the bazooka prophet. And today we are going to be talking strictly on the calculation involved in one of the properties of the colligative property. It's talking about what we call the osmotic pressure. Now we should understand some basic facts before we enter the calculation. That osmotic pressure is the pressure that is required to stop what osmosis, and that we are aware that osmosis simply defined as the flow of solvent from a dilute solution to a more concentrated solution when it is being separated with a semi-permeable membrane. So we continue. Now in this video, we are going to be talking about the calculations. Now we should understand that the symbol for osmotic pressure is pi, and that the question on the board is 1 liter of an aqueous solution containing 20 grams of hemoglobin has an osmotic pressure of 5.9 torr at 22 degrees Celsius. What is the molecular weight of the hemoglobin? Now, as I've always told you in my calculation video, that when asked a question, you bring out what you were given or the parameters that you were given, and from the parameters, you will tend to know the formula that should be applied, and you move on. Very easy. Keep your mind down, very relaxed, and you understand it. Now, these are the parameters on the board. The volume is 1 liter, the mass 20 grams, the osmotic pressure, which is 5.9 torr, which will be converted to pressure in atmospheric, like in atmosphere, which is ATM, which is 7.8 times 10 raised to power minus 3 atmospheric pressure. And the temperature, which is in degrees Celsius, would be in Kelvin, to be 295 Kelvin. And that the formula for it is osmotic pressure is equal to the molarity multiplied by your gas constant. And the unit for our gas constant that we're going to be applying is 0.0821 atmospheric pressure liter per Kelvin per what? Per mole. So what do? We first of all get the what now? The molar concentration. And that from the molar concentration, we will not apply the formula for molar concentration. Of course, you know that molar concentration, which is M, is equal to the number of moles of solute over the volume, which may be broken down again to be mass over molar mass over molar mass multiplied by what now? Which is 1 over volume. So with this, it's solved already. So what do? We get for the molarity, which is equal to pi, which is the osmotic pressure over the, you see how easy it is right now. So what do? We come here, the osmotic pressure is 7.8 times 10 raised to power minus 3 over 0.0821 multiplied by 295. When we multiply, we're having our final answer here. Our answer here to be 3.22 times 10 raised to power minus 4 okay, minus 4 mole per what now? Per liter. Now, but I am not looking for my molar concentration, rather I'm looking for my molar mass. You will recall that molarity is equal to the number of moles of the solute divided by the volume of the solvent in liters. From here now, I cannot get for my answer. Already I know that my molarity here is already what now? 3.22 times 10 raised to the power minus 4 is equal to, I am looking for my mass in gram, x over the molar mass. Okay, I was given the mass rather. The mass was going to be 20 grams. I'm looking for the molar mass multiplied by 1 over 1. Why? Because the volume was in liters and it was 1 liter. So what do? I'll make the molar mass the subject of the formula. I say molar mass is equal to, and I can multiply now, 20 over 3.22 times 10 and minus what now? 4. When okay, when you multiply, okay, when you divide, you should be having your final answer to be 62111 gram per mole, and that is the final answer to the question. Now we should understand that if you look at the steps that are involved here, there are times in a question whereby you can be given the osmotic. Okay, you can be giving your osmotic pressure and asked to look for the temperature in Kelvin. Those, if you can know the formula, you can always substitute the parameter given to you to suit your answers. And on this very note, we come to the end of a question under osmotic pressure. Now, in our next video, we'll walk straightway on orders. For now, I remember humble self and adrenaline, the biological prophet, your friend and your chemist. For now, God bless you.